Welcome to my Nobelium build video. The Nobelium is a bass preamp with bass in, out to your amp, and XLR out to your mixing desk. It is a valve-based preamp based on, well, should I maybe say, the Nobel Bass Preamp. I'm not sure necessarily if it's identical inside. It obviously doesn't have the power supply section. This is only the valve-based DI. The style of the video, I'm going to start with a unboxing, just show you what's in the box. I bought the whole kit. I'll give you a link to the kit. I'll then assemble the kit in almost real time. So the style of the video is that you can build your kit along with me and then just pause when I fast forward the boring repetitive parts. And at the end you should have a really top quality bass preamp. Now, this is the whole warning as with these videos. This is valve based. We do have valves in this. While it is not a beginner project, it's not particularly difficult. However, with the valves, these are running with 250 volts DC. I know it comes off a 9-volt power supply, but it's stepped up inside. And there are capacitors on that 250 volts. So if you're not sure what you're doing, be very cautious once you have this powered up. You can get a nasty belt off the fully charged capacitors. So I'll put a wee warning, as we do in the YouTube intro to the YouTube, and just take care. However, this build they do say is probably an intermediate. I'm not sure necessarily if it's intermediate. I would actually say it's fairly straightforward. So maybe, if you're coming out of being a beginner pedal builder and want to have your first shot at something a wee bit more advanced, this was not too difficult. So I hope you enjoy the build video. So here we have the Nobelium kit as ordered from Das musicding.de website. I ordered this online as a complete kit. It comes shipped in a nice thinnish box. I ordered the standard kit, but in addition to that I did order the JJ drilled enclosure and 3 nice knobs as they weren't included in the kit. So the joy of the United Kingdom deciding to leave the EU. In Scotland we would still be in the EU, but never mind. We had to pay an extra £40 for import duty. Inside the box we have the complete kit of parts. Now I have opened this, but obviously to check it. But so starting off, we've got the drilled in enclosure. So it's all pre-drilled. I was essentially just being a bit lazy. You can see there it's marked as Nobelium. Okay, so we've got that, and then all the additional components come all bagged up. Let's empty the bag out, put the bag to the side. Now flick through this. Okay, so now this is nice. At the start we have got a Nobelium front panel. I didn't see that in the light. I'm guessing this just goes over the top, so that'll be nice. That gives it a finish. Now I don't know if that's part of the drilled enclosure or part of the standard kit, but I was surprised. I didn't know if that would come, but that's good. That makes it nice and professional. Right, let's flick through the other important one. This looks like the PCBs. These are from the original set as Conspiracy to Commit Electronics PCBs. I'll hold that up for you a wee bit. Okay, so nice PCBs, all marked out with all the components, which is important because the build instructions are light, but to be honest, bill of materials and marked PCBs. That's main PCB. We've got a few Daughterboards. Let's see what these ones are. I think that's for the jack and the DI. Hold that one up. And we have got a couple I think are for the valve. Okay, and these just hold the valves at I think 90 degrees in the bag, in the box. Okay, pop these to one side. Then we've got all the components sorted. Now, first bag, they've sorted them all into individual components. So here's the resistors. Now this is really nice. This is a nice touch. I know I used to be able to remember all my resistor codes off by heart. However, they have kindly written, we'll see, fold that up, see if, no, it's probably not going to focus. Okay, maybe about, I've got too much things. But let's, on here we actually have the value of each of the resistors marked out. That's saved me searching online. We also, looks like we've got the diodes in there, so that's all the resistors. We've got another bag here. Capacitors, various electrolytic, ceramic and drop capacitors. That's nice, all set out. What's next? I did say we had ordered the knobs separately, so it comes with, I'd ordered 3 of the knobs online, so we've got the complete kit ready to rock and roll. And let's see, what else have we got here? This looks like my general hardware bag. Hardware, sorry, that's not quite right. Hardware and pots now. All our switches, our potentiometers, these are nice quality looking potentiometers, they're nice. Neat and small, but very nice compared to the days I used to make lots of my own electronics. Open frame jack plugs. Don't know if they're switchcrafts or just general open frame. To be honest, I think they look perfectly good. So that's the resistors. I've got a bunch of hookup wire. Okay, if you don't have any of your own wire. And then the fun bag of active components or larger components. So we have got, JJ Electronic Slovak tubes. This is a ECC82, which is their 12AU7 tubes. So they'll be nice. I used them in it's very similar, if not identical, tubes in my Fender Tweed boutique clone that I made. What else have we got in here? We have got the DI transformer from Unagi Magnetics. That'll be interesting. I mean, I could swap that out for a Jensen, but well, we'll see if people can really hear the difference. This is an E4305 transformer. Second valve. What else have we got in here? We've got a few active components. I think that's our 555 timer, which is in part of the step-up power supply. Some MOSFETs and transistors, again in the switching supply. So these are not actually in the signal path, these are just in the switching supply to raise the voltage up to, I think it's 170 volts inside. What else is there here? Oh, this one's wrapped up. Oh no, that looks like the valve bases. Excellent, nice ceramic valve bases. That's nice. And I said there's the inductor part again as part of the power supply. A couple of LEDs and a few standoffs. Connectors. Pins. Excellent. So that's the whole kit for the unboxing. As I say, there is now a online, sorry, not an online, yes it is online, PDF of the build. It's mostly pictures, but I'm going to use this video to actually take you through the physical build of this. So I'll put this to one side. In fact, I'll probably put all this back in the box and put that to one side. So to say, the other thing, the important thing is the bill of materials. So again, the bill of materials is on the Music Ding website, and so I'm just going to sort of follow the bill of materials on the construction. Now, construction is probably follows most electronic kits in that I tend to follow a fairly standard route in which we will start off with all the passive components, especially the low components on the PCB, because we put the components through, turn it over to solder, And if we put tall ones on first and then put low ones, when you turn them over, they fall out when you're soldering. So I'm just going to take it slowly but surely and build this up, starting with passives, then the next level height of components, say the IC sockets, then capacitors, electrolytic capacitors, and it should be fairly straightforward if we take our time. So here we go with the build. So as I said, we'll start off with the passives, and we could do this as R1, R2, etc. But what they have done is they have packaged the resistors in groups and listed in the bill of materials based on value. So I'm actually going to work through the values as they started. So we're starting with a 560 ohm, which is R8. So as I said, they have kindly, already I have off to the side here, I have just laid out all the resistors. So resistor number 1, as I say, you probably won't see that, or maybe you will. So they have kindly marked on the resistors the values. I do sometimes get the meter out just to check them. So 500 and I used to know this off by heart, so 560 ohms, stick the meter on, here we go, 560 ohms, so that's it. So that's listed as R8. So I'll probably fast forward through the rest of the resistors, and boy, my eyesight's going flipping it. So I'm going to stop here, and I'm going to go and bring up the PCB on a much larger scale on my PC screen just here. Okay, that's me, just found the PCB online. Pictures aren't particularly high resolution, but here we go. So R8, I'll just double check that that actually says R8, that's R8, 560 ohms. So this is also where you may want to put the resistors all one way or not. I quite like making sure my resistors are all pointing in the one way. So anyway, okay, so R8, here we go, 580 ohms. So push through, bend out the legs very slightly, soldering iron to the ready, in the tip, and this is interesting, soldering on camera, but let's see how we get on with that. My iron is up to height. I haven't tinned the joint. There we go. I should re-tin my soldering iron. There we go. There we go. Okay, let's just double check that. It's all looking nice and neat, no cold joints, snips. Okay, so that was R8. Okay, and we will now probably go through, that's how it should look, and your first resistor. Okay, so we shall probably fast forward, but the next one is 1K. There's 3 of them, R3, 4 and 6. Not so much fun getting older. I used to be able to see all this. I must admit my eyesight is great for long distance driving, but the up close stuff is getting slowly but surely harder to work with. Right, let's get these soldered up. Let's get this properly tinned a wee bit better. Okay, here we go. So just on the joint, on the PCB, make sure good heat gets into that. Again, good heat in there. I do remember as a kid making my own PCBs, and certainly you didn't have solder mask, so you're forever fighting solder joints between components, but solder mask makes things, life so much easier these days. It should be, so R1 is, there you go, over by the power supply section. Yeah, that's also quite handy. Okay, so R1, 2.2K, it's just next to the inductor in the step up. So yeah, so valves are going to have a high voltage power supply. Now, how do you get a high voltage power supply when you're powering the pedal off? I need to check, I think it's a 9 volt standard pedal power supply. Well, you use a charge pump circuit. So essentially what you do is you take your 9 volts, switch that into an inductor and a capacitor, can't remember which way around, probably into the inductor, charge up the inductor, and then you switch off the inductor, and the magnetic field and the inductor collapses, and there's a reverse voltage, I think it is basically, and that pumps into capacitor and keeps pumping up the capacitor. So essentially you're able to charge up, I think that's how it works. It's a long time since I've designed these. You charge up the capacitor, and that capacitor gets up to the voltage, and then through another sort of regulator circuit goes out to your 170 volt power supply. I should double check it's 170 volt. Let's look at the schematic. Let's look at the schematic, see what it says. Oh, sorry, that's wrong. 250 volts DC pumps out. I should maybe bring that up on the YouTube video. It's 250 volts driving the valve power, the valve themselves. I think it's called B+. 170 volts is normally the voltage you would be using on Nixie tubes, because I've built a few Nixie tube clocks, so that's where the 170 volts goes. Sorry, I get mixed up. Okay, next one up, 2.7K, 2.7K. Build document. So essentially, the detailed build instruction says assemble main PCB, which is this. Solder the components to the top of the main PCB and clip excess leads from the bottom. That's it. So let's finish off that. So that was the 2. Now, as this is my first YouTube video with me actually soldering, I'm sure comments will be full on, if anyone actually watches it, on soldering technique. Yes, there's plenty of stuff out there on how to solder. I've been doing this for a while, but don't necessarily think it's particularly great, but it works for me. That's 18K, 47K, 47K, one of these. So I have watched a few YouTube videos. I even watched an interesting YouTube video on the NASA approved way to solder. Yeah, it's going to take a long time to build your spaceship, but I suppose back then they had the money. Interestingly, for vibration, soldering isn't always the best technique, and an old-fashioned technique I used to use back in university to mock up digital computer boards was what we called wire wrap. That's an old technique, but essentially consisted of wrapping wires around sort of square pins. And you'd think, no solder. But because they were not such solid joints, there was a degree of flex in them. So while they were very, very good, the flex also meant they were very robust. And that's what they did in spaceships, but I'm not going to bore you with my other spaceship hobbies. That's one. Yes, so the current trend is a nice DI box, such as a Nobelium or ones of a similar name, and an HX Stomp line 6. So it does seem to have slightly gone full circle. So this is part of my project that I'll be probably moving back to, well, trying this out. So I'm trying out this as a preamp to replace the Sans amp, which is still a very good preamp. I don't think I'll part with it. And an HX Stomp, but that's going to probably, whether or not I'll replace, on the pedal board just now, there's a Boss Octave pedal. I did have an OC2, but could never get on with it. And I went to an OC5, which tracks much better for me, that is. I'm sure it's not the same for everyone. And a Boss Chorus pedal. Up the front there's an MXR compressor. Can't remember the exact model name, but it's the pretty famous MXR bass compressor based on a studio compressor. So the compressor will probably stay on the board, then go into an HX Stomp, and then is going to go to the Nobelium Preamp / DI. I do have a volume pedal as well, which is quite nice to have, just even for muting, or you can use a tuner, or I can use it for swells. So that was the 220k, nearly done on the resistors. There's a 1 meg, there's 3 of them. And we're back. Just recharged my camera. The camera just ran out of batteries there as I was about to do the last resistor. But of course, this is where you've got to take care and make sure you record everything, and not just record everything, but check everything. And I had swapped the 10k and the 10 meg resistor, so a wee quick desolder, swapping them around. But that's all the resistors in the first board. Now there is one other resistor, a 51 ohm resistor, and that's listed as being on the transformer DI output Daughterboard. That's interesting. I'm looking for the first time. And that, let's hold that up. You can see there the transformer board. There's 2 sets of holes there for the transformer. I'm guessing that's to be able to cope with different models. Anyway, there's one last resistor on that. Up in this corner, my eyes are just picking that out. 51 ohms. And to stop me making the mess I had before, let's just double check it. There is only one resistor left, so this should hopefully be the 51 ohm resistor. Let's put that on the meter. And there we go, 51.3, that's pretty close. So just like the other resistors, let's just finish these off. I'll just insert that into the right place. 51 ohms, there you go. Put that on, splay the legs out very slightly, solder time. Okay, if the light's changed, it's because it's now evening, so I don't have daylight, it's just my desk lights. Okay, there we go, 51 ohm resistor in. Okay, so we shall go back to the main board and think about what's next on our board. Let's go
In the bag of the small components, it also included 3 diodes. Now let's have a wee look at the diodes. If they are all exactly the same, they probably are. I'm just looking up the parts list. Alright, maybe not. 1, 2, 3 different diodes. A Schottky is D1, a rectifier, and a generic rectifier. Okay, so there's a that's interesting. D1, which I guess is in the power supply, which is low. So D1, just scrolling up in the schematic to the power supply on the PC. Right. D1, a 1N58171851, a Schottky diode. And it just looks like it is in the input circuit to stop reverse voltage, destroying that. Now this is where I have to get the magnifying glass out, and I don't know if I'm going to get the I might have to get my really big magnifying glasses out. I'm going to have to get my really big magnifying glasses out. Right, these wee things, they're a bit of a joke, but I do put them on my eyes, and I can actually read very, very, very small components. So you really don't want to see this, but I hold this up very close. And this is, this one here, let's hold that, ZP9IN. There you go, IN5817. IN5817. Where's that one go? IN5817 Schottky diode. There we go, straight away D1. So that'll be down in the power supply section, which is down here. D1. Where's D1 go? Well, actually, no, it'll be up here on the input. Okay, and you can see here, I'll hold up the camera, there should be a stripe there for the polarity. That should be straightforward. Okay, so tape off, and in here, making sure it's the right polarity. Excellent. Put this one in, that's quite tight. Let's, I should have bent these legs a wee bit tighter in. Okay, let's pull that through. Now, before I solder this, I am going to get all the diodes and check them. Now, that's quite tight, but there we go. That's that one. Just have a last check of these. That's that way around, that's that way around, and that's that right way around. So I've got the polarities right. Now there's one more component that was in the bag of the small resistors and diodes, and that was a trim pot. Okay, so that trim pot is listed down there as XLR out. Again, looking at the schematic, it seems to just be a, I was wondering if that was some sort of bias in the valves or anything, but no, it just seems to be a volume output to the XLR. So I'm guessing it depends on if you want to run that into line in stages or mic in stages. I guess it just allows us to balance how hot the output of this DI box is to the desk amp or whatever that you're running on the XLR. Remembering this does have a jack output as well, separate, which I'm guessing could be for driving into your amp or on stage or however you're running your setup. I've given up my amp a long time ago, my big Trace Elliott rig, and from the 80s, and am these days pretty much always on IEMs. So that was the first bag of components. resistors and diodes. Let's get the second pack of components out that go on this board, and that is the diode pack. Oh, that's flaring quite a bit on the camera. Okay, the bag of diodes, what am I saying? Bag of capacitors. Now, I could stop the camera, I'll just let it run for now, but I'm going to do the same again and sort these out. So in value, now these are pretty tiny, so let's have a look at that. The very smallest one should be a 100 pico ceramic, which this looks like ceramic 101, if I remember rightly. That's 10 times the 1 is a 10. I shall just double check that, but again, my age, I used to know all this off by heart. (101) is 100 picofarad. Okay, so I spotted it first time round. So that's the smallest capacitor, and that is going in at position C3. Let's bring up that. So C3 will probably be over the power supply somewhere. Interestingly, I've got another ceramic capacitor here, and don't know where that goes. I think it might be in 10 nano 100 volt. I wonder if that's on the Daughterboard for the XLR. Where's my mouse gone? Where's my mouse gone? There we go. Too many screens. Right, interestingly, they don't seem to have a nice close-up picture of the XLR Daughterboard. That's a pity. I shall maybe leave that to the side just now. Again, get magnifying glass out. What does that say? C1 10 nanofarad. C1 10 nanofarad. It's 103. 103. Okay. Now there's interesting. Have I got this wrong? So that's a 103 capacitor. Let's see what that one is as value. 103. 103 capacitor value. Didn't need the J. 103 capacitor value. Okay, is that's 10 nanofarads. That's a small one, I put it down. That's 10 nanofarad, which probably is going in there. Let's stick it in there for just now, and I shall go and check the other small ceramic capacitor that was elsewhere. What value that one was, but that might be the giveaway if the two ceramic capacitors were different values. Put that one through. Right, what value was that ceramic capacitor there? That was C3, was a 100 picofarad. Okay, let's have a look at that. So 100 picofarad. Can't remember the code that should be on that, but let's look at that closely, see if I can see it. Where'd it go? 101. So that's 100 picofarad. And yeah, that's correct, because it's 10. So that's the 1 0, and the 1 is the multiplier. So that's 10 raised to the power of 10, or times 1 to the power of 10. That makes, so it's 10 by 10. That gives you 100. Whereas this one was 10 with 3, so that's 10 with 3 zeros. So that's 10,000 pico, which is 10 nanofarad. That goes on the XLR daughterboard. Excellent. Okay, so that just leaves us with the. I can trim that one now. We're good with that. Okay, so that leaves us with the electrolytics. Okay, so let's just read off the value of the electrolytics. I just don't need my silly glasses, but still need a magnifying glass for that. Maybe I do need my silly glasses. No, it's around here. That's 100 volt, 1 microfarad, 100 volt. So that's 1 microfarad. It's only listed as 50 volts on the parts list, so we'll leave that to the side just now and identify the others. This guy here is 220 at 16 volts. 220 16 volts is C14. Okay, this is capacitor 14. Let's find that in the board. Capacitor 14. Okay, it's down here. Now this is where it's polarized. So we can see the stripe is going to go to the, you see the stripe. So the stripe is going to go to the associated stripe on the board. So that's 220. Okay, so that's that. Let's get all these capacitors identified and let's leave the last one. So this guy here is so that looks like I've finished the bag of capacitors. So we'll need to look at, that one looks a wee bit not so nice, I'll just reflow that. Often it's just a case to put some more heat in and reflow the joint. Okay, that's the capacitors in. What have I still to do on here? Right, I have got to do the socket for the IC, and I've got the inductor to do. And then I've got a couple of MOSFETs, or transistors. Oh, my coffee's getting cold. Pull over my next box of parts. Let's look. See if I can get these. So let's have a look in here. Right, stick the tubes to one side, stick the transformer to the side. Okay, here's the 555 timer and the. Okay, now obviously the IC we've got to get in the right way, and in an IC there's normally, let's hold that up, there's normally a wee notch. So that wants to follow where the notch is on the board. Just make sure the orientation is the right way around. Now, this is where if I turned it upside down it's going to fall out. So we just normally just knock over the two corner ones to hold it in place before we solder. We want that nice and tight to the board. Okay, that's staying tight-ish. I shall maybe stick my there we go. Now I'm just going to put my finger underneath and make sure that's sitting tight to the board. That's fine. Okay, I can. Okay, make sure I don't push the pins out the sockets. These sockets can melt very quickly, and the pins will. So I don't want to put too much heat into these pins, such that the socket doesn't get too molten and deform. I do need to put some heat in. There we go. Is it flowing? Okay. So that should be the IC in. That's looking okay. And a wee bit touch more solder. To be honest, you don't need too much solder, but you sort of feel a bit mean if there's not enough solder in the joint. Reflow that one. Reflow that one. There we go. Okay. So what else do I need? I need the inductor. Let's have a wee look in the parts. Let's see what comes out next. So here is obviously the inductor and the power supply. Now inductors are not polarized, so that's just going to go into L1. There you go. Yeah, stop sort of, now that the board's filling up, I'm not referring to the parts list as much. I should really check these off. I'm being a bit lazy because I've built so many of these things before. Come on. Okay, that's the inductor in. What's that? Popping up. Oh, it's a new YouTube video. David Gilmour Looking Strange Tour. Now that was a gig I saw a couple of weeks ago down at the Royal Albert Hall. I went to see David Gilmour. That was quite an epic gig. Okay, so here is the sort of power MOSFET. That's going to be pumping the current in and out of the inductor capacitor for the high voltage. Again, while it's high voltage, remember at the start I did say there is a warning. When this thing is powered up, you need to be careful. There are high voltages and capacitors which can charge up. Can give you a belt. And I know, I have had a belt off a valve or a tube amp, as you Americans would refer to them, and it is not nice. I was hacking around with an old gramophone system, thinking I could build a valve amp out of this. I hooked my Stratocaster up to it, and I didn't really check the circuitry, and my strings were live, so that was pretty classic. So yes, I got a good belt off that, and thankfully modern electricity in the house did trip the electricity and saved me. I'm not sure this would exactly kill you, but it's this, because it is only powered off a 9 volt, so the current wouldn't be too high, but as you say, it's current that kills rather than voltage, I think, if I remember right. Okay, one more transistor. Where's that? Q1, there it is, down there, 2N3904. Let's check that. This is a 2N3904 Q1. Okay, again, transistor, 3 legs. Hold that up the camera, and so it is a flat on one side, so you can see which way it goes. Okay, that goes in circuit. There you go. Let's get that. Okay. So that goes there. Again, transistors are fairly sturdy, but you don't want to necessarily put too much heat into the legs. When I started as a kid, I'll probably be even in the 70s, transistors were much more sensitive, and you did have to put heat sinks on when you were soldering them, just to make sure you wicked away the heat and it didn't go into the body. Let's have a wee look at that. That looks perfect. Okay, so here's the PCB so far. Let's see what I'm missing. Okay, so you can see, I'll hold that right up there. Okay, so I try not to get the glare. Okay, so am I missing anything over here? Now, these are where, these bits here are where the valves, daughterboards go, so that'll be later. That's done, that's done, that's done, that's done, that's done, that's done. Hey, I think we're pretty much done on the board. Excellent. Okay, attach the pots. Connect the pots to the bottom side of the main PCB, so onto there. Solder them in place. The pins on the side of the body are for stability and also ground connection. Okay. It's recommended that you solder them in addition to the 3 main signal pins. So you do the pots have got 3 pins, but they also have 2 pins at the side which are holding them in place for printed circuit board mounted. So let's get these pots out. Don't know if they're all the same value. And there's a couple of switches here as well. I'll have a look at that. Okay, I think we use one of them. Okay, so let's turn it over, and you'll see that there's a 250, 250, 250K, 250K bass, treble and volume, so they are all identical. Let's see if that says, let's get the magic glasses on, read the description on it. It says alpha EA1, let's see if there's a value, there you go, A250K. Okay, so these go straight onto the board. Hold that up. You can see the 3 pins go in, and I'm holding that up. I can't see it too well, but there you go. Let's hold that up. The 3 pins go in, and the 2 side pins. Right, I'll hold that while I'm doing it. There you go. The 3 signal pins going in. Oh, that's a wee bit finicky. I don't know if that's a word anyone else uses, finicky, but let's try one that's maybe not got bent legs. See if that goes in easier. Nope. There you go, that's 3 pins, and then the Yeah, that's better. Okay, so we can see that. Let's see if that's there. You can see that's 3 pins, and we also have the side pins coming out the bottom just here. Okay, so I'm going to solder that one on its own first. Give that a check. These are all good. It does say we also put the switch down. Let's see. I pulled out 2 switches, did I? Okay, I'd left the other switch in. These look identical. I'll leave the mounting hardware on just now, but that obviously just sits there nicely. That's quite cool, mounting that on the PCB. Now this is going to be sort of that, because the switch contacts are quite tough and short. I am just going to hold that in from the back, and this isn't a recommended solder technique, but I'm just going to try and get the first one started. Need to load up the soldering iron with solder. Don't copy this at home, guys. This is not a great solder technique. I just wanted, okay, that's in and holding. Right, now I can solder the others, and I'll come back and properly flow that one much better. Okay, again, because these will be quite large pieces of metal, it will need a wee bit more heat into the joint. Sorry, if that's viewable. It's taking a lot of solder. I'm going to come back to all these. I'm going to probably do them again. Try not to put too much heat into other components in case I damage them, but there you go. See how much solder goes into that? There you go. That's balled up, so I haven't had enough heat into the PCB. Let's see if we can flow that a wee bit more. It's not a great joint. That's better. Now it heats into the board. Okay, so that's that switch in there, and that's nice and solid onto the board. Okay, so it says to do that. It also says in this piece of instruction to put the standoffs on. So again, let's find the hardware bag. Hardware bag, where's my hardware bag? I put the bag of hardware. Is that in here? Yes, here we go. This looks like standoffs. So basically they're putting the standoffs in. Okay, so that's coming in from this side and coming up here and going to the okay, it's one standoff and the second standoff. 2 more screws, we'll check where they're going. That might be on the Daughterboard, but we'll check that in a wee minute. Careful. There you go. And and I shall just give these a nice tweak. Okay, so that looks like that's the main board built. Good. Right, let's look at the daughter board for the XLR output board. Okay, so it does look like that XLR output board only has which way around. Okay, so there's a switch there, then that's the resistor, so I'm looking again, so we need that other switch. I think that's the ground lift switch. So that goes on this side. Okay, excellent. Let's again. Okay, next item is the XLR socket. That's a PCB style XLR socket, fairly straightforward. I'm just going to plug them in there, and there is a fourth pin. I'm guessing that must be a ground. Okay, let's solder that one in. I'm guessing there's no reason why you couldn't upgrade some of these connectors with a genuine nitric, etc. They're all good options for upgrades, but to be honest, in most cases you're not going to hear any difference between the different connectors. I know that's controversial, but never mind. Now, we've got the transformer to go in now. I haven't seen how the transformer mounts. So the transformer has got 8 legs. And goes in. Nope, might need to take the hardware off the switch. Now, the question is, how do I tell which way around that goes? Because it looks like it can go. Well, that's quite tight in there. That's interesting. Okay, folks, maybe you want to have your transformer in first. Okay, now it's going to go just tight between these two components. Now, I'm probably going to go and have a look at the data sheet because I'm not sure if there's a right way or wrong way to go. Okay, kids, so a couple of things. I would maybe do your transformer first before putting the other two when you come to do yours. But I'm going to put that to one side just now because I'm going to probably look that up a wee bit more. Let's put the hardware back on the switch for safety. It's not safety, so don't lose it. I'll maybe take a break and come back to that. Okay, that's that daughter board. That's my main board. Right, next thing to do is to do the 2 valve boards. Now, I'll put my spare pieces of hardware away for safekeeping. Keep my workplace tidy. Okay. So I'll need these 2 boards, and I need the 2 valve sockets. 1, 2. Interesting, that's quite cool. So, okay, if you can see that, it says there, if I get tube socket here. Okay, and then conspiracy to commit electronics is on the other side. So tube socket here means exactly that. We put the tube socket on that side. I'm going to just double check because it does give me a link to a page that tells me how to do this. While I'm pausing the video, let's actually have a wee look at that. Have a look at that. Okay, attach the tube daughterboards. After assembling the tube daughterboard as per these instructions, so it takes me off to another document in the link, and it takes me to a picture about sushi box. Okay, and this has got to assemble the... So, actually it's suggesting that I put the right angle connector on first. There should be a couple of right angle connectors on here. Number 1 and number 2. Okay, and these go on the same side as the tube socket and point that way. Okay, so again it refers to a... Okay, so this is going to go at the same side as the tube socket here. Okay, again you want to make sure that that is nice and flat and sitting in before we solder that. So solder that. Okay, let's have a look at that up close. They'll look good. And then the valve socket is going on this side here, and the same side. Oh no, they don't. They just solder the LED. Okay. So again, LEDs need to have the right way around. The long leg is the node, which is the plus, so that's the long leg goes to the plus. It does say, now it's interesting, the build instruction does suggest putting a valve into the socket so you can see that it's not interfering. Let's get a valve out. It's always nice to unbox a valve for the first time. There we go. Yes, I think these are exactly the same valves as I have in my Tweed Deluxe. Okay, so that's going to go in there. Oh, it's quite stiff, which is probably good. It's very stiff. Okay, that's it going in. Sitting there. Okay, there we go. So we're going to put the LED around the side. You see that there? So this the LED is on the side there. I'm just going to add some backlighting. Of fakery, but hey, that's what we're all about. Nice bit of fakery. That's that one. That's that one. don't all comment on my soldering technique. I know it's not the best. It gets there though, and they've been quite reliable in general. Okay, so that's the two. So I'll just take that bolt back out. Yes, that's the two daughter boards built. That's quite simple. Put it all back in the box. So, what does it say about the daughter boards? Okay. Attach the daughter boards. After assembling the daughter board, slide pins into the stands in the board until the daughter board sits flush with the main PCB. Then solder the pins in place from the bottom of the main PCB. Right, okay, so I'm guessing what they mean bottom is this side. Okay, so going by the picture, 12AX, 7 left, that's going to go in there like that. That looks like it, can you see that there? Okay, so the PCB goes in there like that. And you're going to solder it from the side as the pots. Check against the pictures, but that looks like how they intend you to do that. So, first one in. Okay, so that's pretty much the board made up. I've got four sets of wires coming off here. I've got an input jack, output jack, okay, power, and I have the daughter to the XLR board. So let's go cables. Now, in the build instructions, they've just done this all in black. No, it's actually make these quite nice. So take some 1, 2. This is nice. 3, 4 blacks for the grounds, and we shall use a red for the power. And I do like yellow for my signals, just because that's often how it's been done in the amps. When you're doing a hand-wired tube amp, it's often yellow. So these are coming in from the bottom. So we've got our input and ground. So input, and then here. These are multi-strand wires, so be quick tin before putting it in. Don't want too much, and it won't go through the hole. That's ground. It's in there. That's soldered in. That's my ground. Okay. A black one for ground. Okay, so here we are with the main board finished. Okay, hold that up, let you see that. Okay, this is pretty much finished, that board. We also have the XLR, the balanced output board. I still have to put the transformer. I'm going to look online after this, make sure I get the right way around. That seems to be all the components apart from the sockets and a bit of hardware to do. That's good. There is a small 3-pin header. That's interesting. I'll have a wee look at the instructions and see where that goes. But that's it for tonight. Okay, and I shall pick up the video in the next day or so and do the final assembly into the board, into the box. Thank you. Okay, welcome back. Where we had left off, we had completed the main PCB, and the last thing you saw me do was to add the flying leads to the there we go, let's get that way, to the jacks, power, and to the DI board. Excellent. Okay, now you saw earlier that I had started on the XLR Daughterboard, and I'd put the switch, resistor, capacitor and XLR socket in place, but I wasn't sure which way around the DI transformer went. So anyhow, I did some reading on that, and we will see the DI transformer there. See, there's a red dot up there, okay, and that there is 8 legs. So the red dot indicates pin number 1. So where does pin number 1 go on the board? Well, like an IC socket, what they've done is they've put a square pad at pin 1, which is up in this top corner here. So your pin 1 is going to go next to the switch up here, that side, okay? Now, you'll notice I have removed the switch from where I had put it yesterday because it's a very, very tight fit. I also just very finely just took a millimetre off the side of the XLR, okay, just to make sure this sat in. So I shall now, it was a wee bit finicky, but I straightened up the legs, and hopefully this will go in fairly straightforward. One side and then the other side, there we go. Okay, so pin 1 you can see up here. So turn that over, and I'm just going to lay it up there because it's hanging off the side of the jack. There's my soldering arm. Let's get this soldered in place. Okay, and just follow our standard soldering. As I say, it does look like they've modified this board or sort of made this board capable of taking different transformers. I looked up the Jensen version of the transformer. I don't see it easily accessible in Europe. I can get it on eBay with horrible import fees from the US, but this transformer, reading up on the kit website, is a custom-made transformer to the same specs. Now, yes, I know everyone will say it's not a Jensen transformer, but hey, I suspect it'll be pretty close, and it's probably the single most expensive part on the kit. Interestingly, when you have a look at the schematic, the layout of this board is absolutely straight off the textbook of Jensen on how to create a passive DI. So we've got a unbalanced signal coming in here. It's going to the transformer balanced out to the XLR, the ground lift switch, and the RC is just I think it's just a wee bit of a low pass filter. Anyhow, so I think this might be troublesome now to get the switch in because it's quite tight. So I'm going to push that switch in. No, it's not going to go in neatly. You can see how tight that is. Okay, so I'm actually just going to take my snips and cut a wee bit off the pins so I can get this in just a millimetre or so over. Whether or not that will foul the case, I don't know. And if it does, we might need to foul the case a wee bit. Just check these pins are through. 1, 2, and 3. I'm going to hold the switch in place. Again, some unconventional soldering technique while I'm holding this in place. Solder. Okay. So that is really the construction finished, bar starting to put everything into the main box. So here's the main box. We've got jack and power. Down the side we've got XLR, and there's the switch. This is going to be fun. Let's see if that fits. Right, I am probably going to drill that hole out up one size. Well, it's sort of there, it's not quite. Okay, so we'll stop the camera and I'll go and do that before mounting any more of the hardware. Okay, catch you in a minute. Okay, so that's me back. I just drilled that hole out and just drilled that out to 9mm. So the XLR module just comes in here, through there, plenty of space, and 2 self-tapping screws onto the XLR. Now that's interesting in that that is the first thing that's slightly either been missed or I have misplaced, is I couldn't find any of the self-tapping screws in the kit. Now that may very well be my fault for misplacing them in just my general junk, or they've been missed, but thankfully I have a stock of these anyway for when I'm servicing mixing discs. I'm just getting a bigger screwdriver. I'll screw this board in place. There we go. This one here, with them tightened up. Don't want to over tighten it. Okay, so that's my daughterboard in place, and that switch is going reasonably freely. Okay, perfect. So the next thing to do is to mount the power socket and the jack sockets. Now you can wire this power socket up whichever way you like. I think the piece that's got the long flat, you can see that, is the center pin. Now, interesting for the electronics guys, the world generally has center positive on power supplies. However, the convention generally seems to be on guitar pedal boards that the center is negative. I'm sure someone might be able to explain the historical significance of that. I suspect this is a Japanese thing. I think often in Japan the center is negative because it's very much Roland, Boss, etc. It's interestingly, I've got Yamaha keyboards and I've got Roland keyboards, and they are different polarities. So most of your pedal board power supplies generally are center negative. Put that there. And tighten that up. 13mm socket. I think it's a 13mm. Yeah. Let's get that. Pretty tight. Excellent. And then our two jack sockets. And again, there are a variety of ways that you can wire this up. Alright. So negative is going that way, so I think I'm going to do them this way around. Okay, that's the sockets and power in the board. Okay, so now the next thing to do is actually to mount the main board. So we want to take the washers off the pots, and I think I know I mentioned I wasn't sure if the front label, or whatever you want to call it, the front decal came as an extra. Looking at the PCB kit on its own, it does seem to show the front label, so I think that all comes as part of the front. Okay, so we then mount this upside down like so. So this should just slot in the box here. I should have done a test fit while you weren't watching, but the camera is rolling. Let's see how this gets on in. Quite tight, but I guess it should be. That's just tight in the case. That's neat. That's that. That standoffs are in. The switches and pots are in, and the switches in. You can see there's two standoffs there. So that's looking good. So there's the nuts for the pots. Put that one on. Alright, we're still to put the front cover on. I'm just being a wee bit too quick. That's interesting. I don't know if there's a lot of grip for the front cover. The front cover's quite thick. Thick the front cover is. Okay, we're going to maybe be quite tight to get nuts on there, so I don't think there's going to be space for the washer. Let's just go straight with that nut on top of that potentiometer. Am I grabbing it? Yes, I am. Good. Am I getting a nut on this potentiometer? Got it this time. Oh, that took a wee bit of hassle, but got it in the end. Here, let's try these ones. That one goes on, tighten up. That one goes on, and tightens up. Does it? Yes, 1, 2, 3. Okay, so that was a wee bit more hassle than it should have been, but hey ho, that's me. And then I'm just going to put washer, lock washer, and small nut on the high pass filter switch. Now it's interesting, we'll maybe talk about that if I have a look at the schematics with you all online. This high pass filter I've calculated out was something like 150 Hertz, which seems quite high, but so that's flat, and that'll be a roll off on the bass. I guess certain basses, I guess my Stingrays, I like lots of treble for attack. That's on. I've got two other screws. Where are those other two screws here? And here we go. There's a completed unit. I'll need to wipe it down from greasy fingers. Switches, pots, boards are in, all sitting nicely. So just the jacks to hook up. And to do that, I'm going to go and get my wire stripper from the van, so I can do this neatly. And I shall be back after I get that. Okay, it's me been down to the van. Got my wire strippers, my favourite strippers. And we are now going to hook up the jacks. So negative is going to go to there. I'll just snip that there. Strip a wee bit back. See, okay, not the most beautiful, but there you go. And always make sure you're getting lots of heat into the both parts of the joint. So the solder flows, it's flowing nicely. Now, if I can remember the right way, the way around this went, the centre pin, that's continuity. Centre went to this pin. Okay, that pin there, let's say the one with the sort of longer view at the back, longer piece of exposed metal at the back, is my centre pin, which is negative. There's two pins going to the earth and the signal. Yep, so the two holes connector here, sorry, in the daughterboard here, the one nearest the XLR looks like that is ground. I'll buzz that in a second, and then the other one is signal, so just buzz that very carefully. So that should be ground, so that's on the ground pin there, and depends if the ground lift switches in or out. Let's flick it the other way. There you go. So grounded is for info. Grounded is with your switch down. Ground lift is with the switch up. Lift up, ground down. That seems reasonably easy to remember. spares. Okay, so that's really about us. Just to put the knobs on. But before we go any further, we're going to test this and see if power comes up. So first thing I need to do is find the 555 timer chip. Now it's in the parts here. Where's my parts? There's a valve, there's a valve. Where did I put my 555 timer? Oh, no, yeah, it is. It's still up here on the desk. I'll tidy it away. Can't remember if the 555 timer is static sensitive, but always with grounding yourself on something. Just bend these pins in just so they're nicely lined up. Nice pair of flat nose pliers. Bend down just very slightly, and they're always a bit splayed out. Okay, 555 timer again, making sure pin 1 marked with a dot there goes up to pin 1 on the socket, like that. That went in nice and easily, that's it. Okay, so don't forget, there is a warning in the instructions about making sure you put that in before powering it up, because if you do that, if you don't do that, then some of the MOSFETs, or the MOSFET, can get overheated as it's not switching. Right, valve in. There you go, I think that's it. Oh, well, these will be robust if that's in. I think so. Right, we're very close to powering this up. So, 9 volts in here. Looking at the schematic, this just seems to drive the step-up power supply to 250 volts, and the 555 timer. The 555 timer, if I recollect, is not overly sensitive to voltage, so it could probably take quite a wide range. So I have power supply here. I don't have my proper pedal board one, so I've, okay, multimeter's gone to sleep, so I've just cut and put a adapter on. It might look like it's wired the wrong way around, but it's, as I say, because pedals are center negative. I'm going to plug that in, perfect. And what I'm going to do is hide my face from anything going bang, and I'm going to plug this in. And I want to check if the LEDs come on. If the LEDs don't come on, then I'll disconnect quite quickly. Okay, so 3, 2, 1, in. LEDs are on. Oh, they're nice. Coloured LEDs. That's cool. So the power is all working. Now, I wonder if my valves are heating up. With the LEDs, it's maybe a bit hard to see the filament of the valves. Anyhow, I wonder if I can see 250 volts. I'm going to put this on the ground, and let's put R9 here. That one there. Let's take that side. Oh, there you go. 227 volts. That's pretty cool. So I have voltage. Excellent. 227. So we have the B plus for the valves. I've got power. I've got lights. I think we're pretty much finished for now. I'm going to unplug that. I do like these coloured LEDs. We are going to get the bottom case. It came with it. And there we go, there's the finished article. Volume, bass, treble. The volume control I think only affects the jack output, but we'll test this further. Low pass filter. Ground is on, is down, up is lift. And my XLR out. Which way around? Yep, so jack in, power, jack out. So if I now plug the power supply back in, hopefully we'll see some nice glowing tubes from behind. Power in. There we go. Nice glowing tubes. I just need to give that my greasy finger marks off that. And here is one completed Nobelium preamp for my bass. So I do need to obviously give it a test and probably adjust the volume pot for the XLR out. But there goes the complete build. In this section I'm going to take you through the Nobelium schematics as included in the build documentation. Now, I'm sure I'll make a few mistakes, I'm a bit rusty in a couple of things in the electronics, however this gives you a good idea of how the system is working. We start here with the 9 volts in from your pedal power supply. That is going to feed through this diode here, and this diode is basically, I think, just for protection, such that if you connect the polarity the wrong way in the pedal, we're not going to blow up. And then this capacitor here is just a smoothing capacitor. This just takes out any additional noise that is on your power supply. The main part of the circuit is here, this 555 chip. Now the 555 chip is a very classic chip that I've been using since I was a kid. One of probably the first chips I would have ever used a long time ago. And it's an oscillator. So the oscillator is set, the frequency is set by these resistors here. And essentially it oscillates, it switches on and off this output. And that output is switching on and off this MOSFET here. When the MOSFET is on, we will get current flowing through this inductor and down to ground. Within an inductor, how an inductor works is it will build up a magnetic field around the inductor. Now, when we turn off the 555 timer, the current will stop. And what happens is the magnetic field around this inductor collapses, generating a reverse voltage, which basically ends up shoving current, I'll probably get this the wrong way, but it's basically shoving current down here, and will be charging up, no, this may be smooth it, but I'll basically shove voltage out this way, and we'll end up charging up this capacitor here. This capacitor here will build up its voltage up to 250 volts, and also this capacitor here will be smoothing, so you won't actually see a chopped supply, you'll see a nice smooth 250 volts. What we have here is a potential divider, which basically divides that around that 250 volts to a control voltage here, which feeds into this transistor here, which feeds into the control voltage here. And so that is basically used to regulate the 250 volts. We're feeding back the 250 volts into the control of the 555 timer. Now you could change this voltage by adjusting this set of resistors, the divide down resistors, and that would change your 250 volts, but we're not going to really do that. The last thing that's shown here is a couple of LEDs.
These are the backlighting LEDs, so not really part of the power supply, but essentially these are the backlighting behind the valves. So while there are semiconductors here, there is no audio flowing through this part of the section. This is basically just taking in 9 volts and generating a nice steady 250 volts that is nicely smoothed out. Okay, we'll now look at the audio section, and the active part of the audio section are built with 2 dual triode vacuum tubes. So we've got basically 2 vacuum tubes, but within each vacuum tube you have 2 parts to it, 2 gain sections. So essentially your bass is plugged in here, and what's really nice is this gives us a very high input impedance on your bass, which is around 10 mega ohms, so it really doesn't load your bass and lets the tone get through. Your signal comes in, and this is a fairly standard triode valve section, and this will amplify or buffer your bass. The signal flows out of the triode here and then goes into here, which is a fairly standard tone stack. The tone basically very much like the tones on your bass guitar, where we've got a series of resistors and capacitors and variable resistors to adjust the treble and the bass part. So your signal's coming out here and into this valve here. The last part is the low pass filter. So here we've got the treble, the output going straight to the second section. However, if we change the switch over to here, so that change that switch here, we add in an additional resistor capacitor, which is the bass roll-off. Okay, so this is all the whole tone stack and buffer, and then it's coming through to this second preamp section, which is basically just doing another buffering of your bass signal, and then we have your bass out here. Sorry, your signal out here. We will see here in the schematic that there is a small preset pot. This basically just allows us to adjust how hot the XLR output on the DI is. I just turned up mine up full. I just like a nice signal to the mixing desk. Now, if we look further here, the signal out of this buffer also goes via this volume control into a second valve in the pedal. It goes via a volume knob. So this volume knob that's on the front panel is only adjusting your volume going to the 1/4 inch out. And so the audio flows through here, and this is where I am a wee bit more sketchy, but I think this is from a class AB valve amplifier buffer. So they've used these two in a sort of push-pull format. I think that's why we've got the diode here. So this is amplifying the positive part, this is amplifying the negative part. But that's where my valve theory is not as good as it should be. Maybe if I've got that wrong, please feel free to add in the comments, as all good YouTube videos say. So basically we then feed out the output to the 1/4 inch jack. Now, this is where my DI output is, but we're still here at a unbalanced output. So we've just got signal and ground. Now, interestingly, they don't have this part, this next schematic in the build document, but I lifted this here from the Jensen transformer page. So this is a standard Jensen schematic for a passive DI based on the Jensen transformer. So while this is showing a jack plug, this is actually coming in from my XLR output here. And so my signal
is coming in here, flowing into the transformer and back out to ground. Okay, and essentially what happens is that the signal flowing through here ends up generating the signal flowing through here, and that is on pins 2 and 3, which give me my balanced output. And then I have a ground here on pin 1 of my XLR. If the ground is lifted, I still have a sort of ground coupling through this resistor and this capacitor, which is exactly the same as what is on the when I traced it on the boards from Nobelium. But if I've got the ground switch on, the ground on this side of my base is connected to the ground out, and so I am fully grounded all the way between my base and the mixing desk or the amplifier or wherever I'm connecting to. So there's a very, very standard sort of passive DI style output tagged on to the end of the preamp. And so it's a fairly, it's difficult to say, it's a fairly standard circuit. There's, from what I'm looking at, there's nothing particularly stand out apart from being built nicely with nice valves and nice values. But it's a circuit I've seen in many sorts of preamps, but it is obviously generating a very, very nice output from my base to the mixing desk.
So here we have the completed Nobelium on my bass pedal board, and it is paired up with the HX Stomp. This seems to be very much the trend in bass pedal boards these days, an HX Stomp and a nice DI. It could be a Noble, but in my case it's a Nobelium. I have left the rest of my pedals on the pedal board for now. I don't know if I'll take a few off. I have the MXR compressor, Boss OC5, as I found the OC2 very difficult to track, and a Boss chorus pedal. These used to be paired up with a Sansamp Bass Driver Deluxe, which has been demoted off the pedal board for now. Now, in the build, there are probably a couple of things that are worth sharing that I would do differently next time. Number one, I found the DI transformer quite difficult to fit, as I had fitted the XLR socket and the switch on the DI Daughterboard first. Next time around, I would put the DI transformer on and then add the switch and the XLR socket, so it's easier to fit. The second thing that I found quite tricky was getting the whole completed board with the controls mounted into the case. Just with getting the pots lined up with the holes in the case. What I would maybe do next time would be I would put the potentiometers and switch onto the PCB and just with a press fit, and then put them all into the case so they're all in exactly the correct position. Then I would solder the backs of the potentiometers and the switch. Just means that the switches and potentiometers are lined up to micromillimeters to the holes. The last thing is, I did find the kit rather straightforward to build. It worked first time, so no debugging. The only preset I set was on the small preset potentiometer inside for the XLR output. I just turned that up to full, so I could get a nice strong signal out of the DI box into the mixing desk. Other than that, the build was rather straightforward, nothing too tricky, just following the bill of material part lists. They give you the resistor and capacitor values, and you just basically match them up to the PCB as you go. Standard build, resistors, other small signal things like diodes on the board, then add the capacitors, IC sockets, and then build your valves, and then a final assembly. So I hope you enjoyed this video. The Nobelium did sound good. I've played it a couple of times now. I'm not going to play it on video as I'm not confident enough bass player to put my bass playing skills onto YouTube. But feel free to drop anything in the comments if you've got any questions on your build, and I hope you enjoyed this, and maybe I'll do some more projects if this proves popular. Thank you.